Okay, so today I'm making this video, grade 11 and 12 students. So I'm making this video for you guys. It's about structural formula and skeletal formula for biological molecules. Now, the purpose of me making this video is simply because it is a pretty big jump. If you haven't taken biochem before or from even grade 10 or 11 chemistry to go and talk about biological molecule, it is quite daunting. So in this case, I'm making this video so that it helps you to slowly ease you into biological molecules in terms of drawing and in terms of how things looks like in real life. Okay. Now, there are a couple of ways of generally drawing these kind of structures. So for example, here of a structure like this. Okay, so this is a biological molecule. So in this case, there are a couple of things that you do to draw this structure. Now, a couple of things first. I'm just going to. So, for example, this one. Okay, now you'll notice that it is uh, these black balls. These are symbolizing carbon. The red one here is symbolized oxygen. Now you see that it can only form two bonds. The white ones are symbolize hydrogen atoms, and they form only one bonds. Now blue, you don't see it in this molecule right now. It symbolizes nitrogen, and it makes three bonds. Okay, so if this is how this molecule look like in a 3D structure, how do you draw it? Because we're going to draw it on a piece of paper, right? So let's look at the structural formula first, because that's the easiest to get into. Okay, so for example, in this example, for example number 1, we're looking at this structure. Now, the easiest thing for you to do is usually find the longest carbon chain, because biological molecules mostly made of carbon and then hydrogen and then oxygen and then nitrogen. So find the longest carbon chain. So in this case, you have 3 carbon here. It's a 3 carbon chain. So I have 1, 2, and 3. And these have only single bonds connecting it. So these are single bonds. So you have 3 carbons joined together by single bonds. Let's start at this one. Okay. This carbon has a single bond to a hydrogen, and then you also have, these will be double bonds. This will be a double bond toward an oxygen. So how do you draw that? So let's keep this here on the sides. You have 1 hydrogen and you have a double bond. So I'm going to draw it like this, oxygen. Now, on the carbon here, I have a hydrogen and another hydrogen. So in this case, I can draw it like this. This is one of the ways I would draw it. Okay, 2 hydrogen to this middle carbon and single bond each. Lastly, this carbon. Now I know we're not using these gray color connectors, but these are also symbolizing single bonds. Okay. So in this case here, I have this last carbon here. I have 1, 2, and 3. So I have 3 carbons. Okay. So this is how this structure would look like when it's drawn as a structural formula. Okay, this was structural formula. What you will notice is that, again, all the carbons have 4 bonds. 1, 2, 3, 4. All the hydrogens have 1 bond, and the oxygen has 2 bonds. Okay? So this is how this diagram, this molecule look like in a structural formula. Now we're going to ignore the skeletal formula. Let's make sure we understand the structural formula well first. Okay, so here's another example of the structural. Now, for this one here, I have, now this is a little bit funny shape. So in this case, if you look, I have My longest carbon chain is 1, 2, and 3, but it's like a T shape, right? This carbon is connected to 1, 2, 3 carbon and then 1 oxygen. So it's like a T shape. So let's draw that out. Example 2. So I have 1 carbon at this carbon here. I'm going to connect to 1 carbon on top. Let's just say arrange it like this. Oops, that's supposed to be carbon. Connect to another carbon and connect to another carbon. Okay? So 1, 2, and 3. Each of these carbons are connected to 3 hydrogens. Okay? So in this case, this one 3 hydrogen, this one 3 hydrogen, this one also 3 hydrogen. Now this one is the carbon that's in the middle is connected to an O and connect to an H. So O and consider H. Okay. So this is how this molecule will look like in a skeletal in a structural formula. Okay. Carbon in the middle forms almost like a T shape with the other 3 carbons. Each of these carbons on the outside here connect to 3 hydrogens. The central carbon connect to an oxygen and then an H or an OH. Okay, there are special properties for this one. So in this case, sometimes you just say OH here. Okay, so hopefully this helps you in terms of understanding how something looks from a 3-dimensional structure, drawing it into a structural formula. Okay, now what we're going to do is we're going to talk about formula. Now what we're going to do is we're going to talk about how do you go from structural formula to skeletal formula. Now, skeletal formula, we do that simply because some of these biological molecules are huge. And we're talking about sometimes like 16 carbon, 20 carbon. So in this case, when you start to draw every single carbon out, as well as the hydrogen that they connect to, it gets really, really tedious. So in this case, chemists or biologists or biochemists develop this skeletal formula. So in this case, it's a little bit cleaner, the diagram, and it's easier to read. Now, you have 3 rules. Every turns and corners and every turns and ends are carbon atoms. Okay, and you only show symbols of atoms that are not carbon or hydrogen. And rule number 3, hydrogen are not shown if they're connected to a carbon. This is supposed to be a carbon here. Haha. My apologies. Now, you do need to remember that carbon form 4 bonds. Okay, so how do you change from a structural formula to a skeletal formula? Let's look at this first example. Now, for this one, as I said, every ends and turns are carbon atoms. So in this case, I have 1, 2, 3 carbons. So I can draw it like this. So they would make by 1, 2, and 3. Okay, I'm just going to draw a number to it so you can help you see it. Okay, so 1, 2, and 3. Rule number 2, you only draw symbols of atoms that are not carbon or hydrogen. So in this case, the only one atom that doesn't fit is the oxygen here. So it's connected to carbon number 1. So in carbon number 1, I'm going to draw a double bond into an O. Okay, you could draw it up towards up like this, or if you want to kind of keep the same orientation, you can draw it like this too. Either way will work. And carbons are not shown if they're connected to hydrogen are not shown if they're connected to carbon. So in this case, all these hydrogens are connected to carbon, so you're not going to draw any of those hydrogens here. So this will be the skeletal formula of example number 1. Okay? So what you will look like here, structural formula, will look like this, and skeletal formula. Now let's look at the second example. So again, every ends and turns are carbon atoms. So in this one, you have a T shape here. So what you could easily do is just draw a T. Okay? Now, every ends and turns and in some ways corners, so to speak. So in this case, this will be carbon number 1, 2, and 3, and 4. So in this case here, I have carbon number 1, this end, this kind of middle part, this is also or corner. Carbon number 2, this is carbon number 3, and this end here will be carbon number 4. Okay? So the ends, turns, okay, as well as these intersections, these are carbon. So carbon 1, carbon 2, carbon 3, carbon 4. Again, only show symbols of atoms that are not carbon and hydrogen. So again, here I have an oxygen here connected to the second carbon. So I draw this one, O. Now, third, hydrogen are not shown if they're connected to carbon. So if you look, all these hydrogens here are connected to carbon. So I will never draw those. But this one hydrogen here is connected to an oxygen. So I can draw it like this. Or sometimes what you will notice in a lot of textbook is they'll draw it like this. Simply because an OH group in organic chemistry or biochemistry symbolize a alcohol. So in this case, they will draw it like this. It's understood that there's a single bond in between. Okay, so hopefully this helps. Oh, I also want to show you one other example. Because sometimes you also see diagrams that are drawn that is supposed to be 3D looking. Okay, and I'll show you what I mean. Okay, so I'm just trying to form this last one here. So now if you look at this, I'm just gonna turn this way. So if you look at this molecule here, I have a carbon in the middle. This carbon is connected to a carbon with 3 hydrogen. It's also connected to, now this is the time you see a blue, which is nitrogen. Remember, nitrogen formed 3 bonds. So 1, 2, and 3. So this nitrogen is connected to 2 hydrogen. This is connected to an oxygen and a hydrogen. And it connects to a green one. Okay, this green one, I believe it is a chlorine. So in this case, this will be a different molecule. Now, sometimes, again, one thing, because these molecules are 3D in real world, but you want to draw it in 2 dimensions. We're drawing it in 2 dimensions. So sometimes what people do is you're trying to draw it so that it shows the organization or the rearrangement of it. Now, what I mean is this. So if I draw it like this, so let's just say if I draw it like this, it means my carbon, these 2 carbon on the same level as my are together. And I will have the chlorine sticking out of the page, sticking forward. I have my OH sticking forward, and this nitrogen will be towards the back. Okay, so one way to draw this molecules to show the organization in 3D would be something like this. I'll draw it in structural first. Central carbon connected to this other carbon with 3 hydrogen. Okay, so they're pretty much the same plane. Now, this chlorine it's kind of like sticking out of the page. So in this case here, I'll draw something like this and I'll shade it. So this here, when you see a solid triangle, it means from like this, it means it's sticking out of the page toward us. So that's chlorine going up. You also have an OH going down but sticking out of the page. So again, you have solid triangle, oxygen, hydrogen, OH, okay, sticking out the page. And lastly, this nitrogen with two hydrogen, it's kind of behind the page. It's behind the carbon, central carbon. So in this case, what you'll do is you will do, so this is like a dash arrow, but in some ways it makes it look like a triangle too, kind of like opposite to these. There'll be a nitrogen to a hydrogen and another hydrogen. Okay. So if you see diagrams like this where you have these solid triangles and you have these dash triangles, so to speak, what it means is that this carbon here, for this carbon, these chlorine and this OH is sticking as if they're sticking out of the page. And for this nitrogen NH2, this is into the page. Okay. So this is a way to show how all the atoms are arranged together in 3D. So I hope this video helps. You might want to watch it again or watch it with some of these molecular formula. You probably should practice drawing a few of these diagrams. It will help you to transition into the biological molecule lessons. Okay, I hope this helps. Please let me know if you have any questions. Bye now.